All right, welcome back to calculus. So we were talking about improper intervals here, okay? And we've got a good one here, okay? This actually talks about a couple of things I'd like to highlight, but we'll see. All right, so here, all right, so let's go ahead and have a look. Let's write the problem down. So we're going to go from negative infinity. Come here. Jeez, we're not playing well. Okay, negative infinity to negative 1. What else are we doing here? We are going from 28x cubed minus 10x, 28 x cubed minus 10x divided by 7x to the 4th minus 5x squared. 7x to the 4th. 7x to the 4th minus 5x squared. Okay. One thing we do have to worry about. Okay, your book does not do this to you, but you might have negative infinity to 1, and maybe it does something like that. But we have to check something, right? So we can't integrate across a singularity, right? So if there's like an asymptote here, all right, and then we go back and then here's 1, like this is not going to be a friendly interval, and you won't know, right? Because it'll look regular. But like for example, if we want to integrate from like negative 3 to 5 of 1 over x squared dx, okay, there's a problem at 0 because now it's going to do that. And negative 3 will be here, right? And then 5 will be over here. And you'll just integrate right across this and completely forget about this. And that's going to be a problem. Your book, like I said, your book does not like to do that to you, but there are books that do, and there are times when that's going to happen. So I want you to be aware of it, even though I don't think we actually have any problems like that. Okay, so let's go ahead and check for some asymptotes here. Okay, any discontinuities. So what I'm going to do is I'm going to factor an x squared out of here, set this thing equal to 0. So we have x is equal to 0 from this. We have 7x squared minus 5 equals 0. 7x squared equals 5. X squared equals 5/7. And x would be plus or minus square root of 5/7. Okay. Now, the square root of 5/7, what is the square root of 5/7? I have no idea. So we're going to say 5 divided by 7 equals, and then go ahead and take the square root of that, so second function of that. If I go and say, you see this little a and s thing, that's the previous answer, right? So even though it's a plus or minus, right, plus or minus about 0.85, all right, is that going to happen before or after negative 1? Like if I'm going to look at my number line, here's negative 1, here's negative 2. Is this over here or over here? And negative 0.85 is about right here. So there is an asymptote here, but since we stopped the integral, right, at negative 1, regardless of what happens, we don't have to worry about this nonsense. Okay, there's also one over here at 0, because of the x equals 0 part right here, right? But again, we don't have to worry about this nonsense. Okay, and we certainly don't have to worry about the positive point, right, because we stop here. So we're safe to do this integral the regular way that we've been doing it. We don't have any weird stuff to watch out for. Again, I don't think your book actually tortures you with this, so I don't feel it's an extra level of difficulty, and I don't feel like it's my place to add in like a ton of extra difficulty to problems that you've already practiced. Okay, these are hard enough. Okay, especially since the notation is the thing I'm grading. Okay, the integrals are actually not that bad, but the notation is in. Okay, so let's get back to doing this. All right, so we're going to have limit as a approaches negative infinity of a, okay, up to negative 1. Okay, we've got a 28x cubed. Let's see here. Do we have a 28x? Yeah, we do. Minus 10x. And on the bottom here, we have a 7x to the 4th. 7x to the fourth minus, what do we do? We have a 5x squared or something, 5x squared, all right? Yeah, all right. Now, what we're gonna do is we could try this by integration by parts. There's a couple of other techniques that you could use here, but we are going to try the u substitution first. I can't integrate it directly, so let's try u substitution. So u is equal to 7x to the fourth minus 5x squared. What's du? Well, that's 28x cubed minus 10x dx. I could swear I've seen that somewhere before. Okay, so in this case, right, our u and our du are really easy to come up with, right? So we have 1 over u and then du here, right? Now I'm going to go ahead and change the limits of my integration. All right, so when x equals -1, okay, what is u equal to? Well, that's 7 times -1 to the fourth minus 5 times -1 squared. Okay, so that's going to be 7 minus 5, 2. So when x equals -1, u is equal to 2. So we're going to integrate up to 2 here. How about we take the limit? Right? We take the limit as a goes off to -infinity, right? Of 7a to the fourth minus 5a squared, right? So in this case, if I divide everybody by a squared, divide everybody by a squared, we're going to have 7a squared minus 5. 7a squared, that's infinity minus a little bit, so that's going to go to infinity. Okay. So even though it went to -infinity, now we're going to positive. All right. Because yeah, that's our substitution here, right? So what we're going to do is we're going to integrate this. So this is natural log of u to du, and we're going to go ahead and plug this in. Okay, so we're going to go from, right, we have limit as a goes to infinity to 2, right? So here we have natural log of 2, right, minus, we don't need a du anymore, we've already integrated, minus the limit as a goes to infinity of natural log of a. And the natural log of a, taking that going to infinity, this also goes to infinity. Do you remember what natural log graph looks like? Right, something like this. So as it's going further and further and further off to infinity, then this is just getting bigger and bigger and bigger. Slowly, but it's still getting bigger. Okay, so this integral diverges. All right, so let's go ahead and plug that in here. This integral diverges, right? It didn't come to a value. We ended up with infinity, so we're out. Great. Oh, great. Let's see what else we want to do. So that was question 8. We'll try question 11 again. Okay, see about that. Did we do this one? No, we did not. Okay. So let's go ahead and have a look at this one. This is 5x. This is negative infinity to positive infinity. We have 5x over x squared plus 6, right? Now, what are we doing with this? We are doing, actually, I'm going to pause our thing for a moment so I can get a cup of coffee. So, pause. I'll be right back before you know it. All right, opted for the red 7 up instead. All right, so here we go. You can't, okay, you don't want to have 2 limits in an integral. You want to break this up, okay? Remember, integrals are adding stuff. So if I have like 1 plus 7, this is the same as 1 plus 1 plus 6, so we could break the 7 up. We could break it up this way, okay? So it doesn't have to be even when we break it up. It could be different sizes, different size regions. That's okay. Normally people go with 0, but 1 is also a very common choice. Okay. So what I want to do is I want to take the limit as a goes to negative infinity of a to 0, okay, of 5x over x squared plus 6 dx plus 0 off to b. We're going to take the limit as b goes to infinity of 5x over x squared plus 6. All right. So notice we're going from a to 0 and then 0 to b. Okay, and that'll span the whole bit. Okay. There's going to be a lot of integrating 5x over x squared plus 6, isn't there? Let's be a little bit clever about this. Mx, note off to the side, okay, that the integral of 5x over x squared plus 6, what is an indefinite integral? What is this going to be? Well, we're going to say let u is equal to x squared plus 6. du will be 2x, right? So what we're going to do here is we're going to move the 5 out. Okay, we have x over x squared plus 6, okay, dx. And what I'd like to do is make it look like my du, right? That's what we're trying to do here. So what we're going to do is I'm going to multiply here by 2 and then divide by 2. See, that's 1. So it's okay to multiply by 1. We're allowed to do that. Okay, no squaring of both sides or anything weird like that. It's just multiplying by 1. Okay, so now this is 5 halves integral. What's 2x dx? What is this quantity? That's my du, right? X in here for u. So this is going to be 5 halves natural log u. So this is 5 halves natural log. And we don't need the absolute values because x squared plus 6 is always positive. X squared plus 6. If you wanted to graph x squared plus 6, 1, 2, 3, 4, 5, 6, it looks something like a parabola with a vertical shift, right? So this never intersects the axis. This is never equal to 0. It's never below the axis. It's never negative. So we're set, right? Okay. Now, where are we? We are here. Okay. So what is the integral, right, from a to 0 of 5x over x squared plus 6 dx? So we're going to have limit that a goes to negative infinity of 5 halves natural log x squared plus 6. Now we're going from a to 0. Now we're going to add 5 halves natural log x squared plus 6, and we're going from 0 to b. Right? Does that make sense? Where we used all of the scratch work here to figure this out. Once we knew what the integral was, we could plug in 5 over 2 natural log of x squared plus 6 and then apply our limits. Okay, that's all we're doing. Right? So what do we have? Well, if I plug in 0, right, we're going to have 5 halves natural log of 6, right, minus, and what do we have here? We have 5 halves natural log of a squared plus 6. Okay, this is limit as a goes to b. Okay, and then what are we going to have here? We're going to have plus of 5 halves natural log of b squared plus 6. Okay, or plus a little bit. And this is limit as b goes to infinity. Okay, minus 5 halves ln of 6. Okay, now these two pieces here, right? These two pieces here, all right? Those cancel because 6 is a number. Natural log of 6 is a number. We can add 5 halves of that number, subtract 5 halves of that number, and get 0. Now the problem here is you can't do this, okay? There is no way to say the natural log of b squared plus 6 as limit b goes to infinity minus 5 halves ln a squared plus 6, right, limit as a goes to negative infinity. There's no way to add these, okay? Infinity is not a number. You can't do this, okay? That's not something you can do, right? We can't do it. You can kind of divide, right? You can say infinity over infinity. We can kind of divide and get a ratio, okay? That's what we do for horizontal asymptotes, right? For rational functions, we divide them. But subtracting, like, no, you're not doing that. Okay, you can't. So we don't know how big this infinity is. We don't know how big that, we don't know how big this one is compared to that one, how big they're getting, how fast they're getting there. They're not really numbers. Okay. It's like, I'm going to take Tuesday and subtract purple, and expecting any kind of logical answer after that, you're full. Okay. You can't do this. You can't do this. They're not numbers. Subtraction doesn't work. Okay. Division, kind of, but not really. Okay, I mean, it does, but we're taking a limit. Okay, so be really careful. Do not do infinity minus infinity equals 0. Okay, that's not the case. We have infinity minus infinity, and I don't know what it is. So it's undefined. Okay, when it's undefined, it's divergent. Okay, because we have no way of calculating that. So divergent, done. So let's go back to this. We're going to say integral diverges, and I should have said similar question because hooray, we got the right answer. But that's, let's see, we check mark. So that's how you do those. Okay, so when we run into an infinity minus infinity, you're done. I really like to ask questions like this because I can't tell you how many Calc 2 students I have tricked, right? Taken off and gotten them to tell me the wrong answer. Okay, so expect something like this. I will try it. Okay, don't get fooled. All right. So let's see here. That was question 11, right? Yeah, that was question 11. Why don't we try 14? Try 14. This is going to be lousy. Okay. Sorry. I wish they used exponential. I wish they used scientific notation here. I really do, but they didn't. So, whatever. So we're going to use a calculator to approximate it. Okay. It's nearly, it's not moving very fast because the rate here, the exponent, is really, 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 really slow, right? So what we have, can I go ahead and do this? Can I say Desmos? All right, and we'll say y is equal to e to the negative 0 point. I think there was 5 of these things, right? There was 5 zeros. Let's check. So 1, 2, 3, 4, 5. 1, 2, 5. 1, oops. 1, 2, 3, 4, 5. 125. So we didn't take E. There we go. All right. So it's a big number. Right? Should be anyway. Well, when X, oh, I forgot X. X. All right. There we go. Nothing like that at all. Subscripts cannot be empty. Okay, come on, give me E. 5 equals E to the negative X. All right. Let's zoom in a lot here. All right. There we go. That's like more of a Desmos kind of a thing. And now let's go with 0.01, 0. Oops. Don't do that. Come on. 0.000, 1, 2, 3, 4, 5, 125. Okay. So look at this thing, right? For as big as you want to get, like it's going down. It's getting smaller. Okay. But it's getting smaller really, really slowly. All right. So it will get smaller because as x goes to infinity, e to the negative x is going to go to 0. But it's not going to go very fast. All right. So when we talk about like what happens between like 0 and 5, like you're not seeing, right, a lot of change in your y-axis. Even when we go out to 40, we're not seeing a lot of change in my y-axis. Okay, it's 1 to like 8 decimal places, or however Desmos likes to do it. Okay, so when you're doing this, okay, this area under this curve, you should expect to see about 5. Okay, because it's almost a rectangle. All right, so when we do this, just realize like it's not, it's going to look kind of weird as far as an exponentials that you're used to. All right, so yeah, they expect us to use a graphic calculator, so we're going to use some numeric stuff here. So what do we have? We said b equals 5, right? That's what we have here, right? It's not going to matter for any of them. Okay, what we're going to do, I should say it's not going to matter, but what we're going to do is we're going to come up with a integral from 0 to b. Just going to plug our b's. What is the integral of e to the negative kx, right? Or e to the negative rx, whatever. Okay, isn't that 1 over negative k e to the negative kx? Right, that's what that is. All right. So when I integrate this, okay, we get 1 over negative 1.25 times 10 to the minus 6. It's a big number, isn't it? E to the negative 1.25 times 10 to the minus 6 x. Okay, that's the integral of this when k happens to be this ridiculous number here, right? And then we're going to go in with a to b. A is equal to 0. What is when a is equal to 0? That's going to be 1. Okay. So what do we have here? We have 1 over negative 1.25 times 10 to the negative 6, right? And we have e to the negative 1.25 times 10 to the negative 6 times b minus e to the 0, right? And this is going to be 1, right? Notice there's a negative on the outside here. So eventually this is going to be 1 over 1.25 times 10 to the negative 6. And we have 1 minus, and then we got to evaluate this, okay? This is e to the negative 1.25 times 10 to the negative 6 times 5, right? It's delightful, isn't it? So you're not going to see very much here. Okay, you're not going to see much changing. You're just going to see pretty much this whole business here, and it's not really going to change. Okay, so I would not be surprised if you ended up with you should end up with 5. Okay, because of our right, our graphic calculator from 0 to 5. It looks like a rectangle, right? We should get 1. We should get 5 times 1. Right. So let's see what we do get. All right. Let's see. We have 1 over 1.25 times 10 to the negative 6. We have 1 minus. Oh, and I got to deal with this. All right. So let's see here. We have, I hope I can do this correctly. Second function, ln, right? We have to the 5 times parentheses negative 1.25 second function EE. That's how you do scientific notation, right? So there's my negative 1.25 times 10 to the negative 6 times 5. Hopefully that will give us something. Oh, it didn't like that at all. I'll bet I put the negative sign here instead of minus sign rather than what I should have done. So let's try it again. So second function e 5 times negative 1.25. Second function e negative 6. Right, so parentheses, let's go. All right. So, lovely. What do we have here? 0.12345. 0.12345, 375. All right, so let's go ahead and take our value and say 1 minus that answer. All right, 6.24999 times 10 to the negative 6th. Where am I? Right here. All right, and then what we're going to do is we're going to divide it by, because it's a division, right? Divide it by 1.25. Second function, EE for our scientific notation, negative, right, negative 6 equals, and what do you know? It's nearly 5. It's 5 out to like 1, 2, 3, 4, 5, maybe 6 decimal places, okay? So our answer is 4.9999, 8, and then some other stuff, okay? We can do the same thing, right, when we don't have 5. We have 40, we have 200, okay? So that's what they want you to do with this. I recommend graph it first, get an idea of what you should expect, right? So I put it at the 10, we should get a rectangle that's about 10, be a little bit less, but for the most part, it'll be close to 10. So whatever they're giving you, realize it's a rectangle, okay? And apply it accordingly, right? I'd probably not ask you one exactly like that. That seems too numerical for me to look at. So yeah, the previous one is good. Let's see, do we want to do more? I'm not going to answer it because it's just going to tell me I've got to do the rest of them. I don't really want to do the rest of them. Okay. So investment versus RT, find the capital value at an interest rate of 5% compounded continuously. Oh, perpetual. Okay, so from 0 to infinity. E to the positive t, right, is going to be yeah, that's going to be a lot. Okay. All right, I'm not really understanding what they mean by this. RT, find the capital value at an interest rate of 5% compounded continuously. Because perpetual, right, that means go on forever. And I don't see an option to say diverge, because if you have an e to the x, as t goes off to infinity, that is going to be an infinite value. And oh, let's try it. Nope, didn't like it. Oh, okay, this is what they want. Okay. So thank you. Okay, so what we're going to do, I needed that as a hint. Okay, we needed that as a hint. All right, so 1500 e to the 0.01 t's. All right, and let's have a look at what's going on here. All right, so this is 1500 e to the 0.01 t times e to the negative, or to the RT, so it's 0.05. That's our interest rate T. Okay, be careful. Don't use 5% as 5. That's not the way it works. Okay, 5% is 0.05. All right. If you say 5% is 5, what you're really doing is now you're charging 500% interest rate. And I'm going to tell you that maybe a career in title loans would be a better fit for you, regardless of what you're going to do. Okay, because 500% interest rate, you're making money on human misery. That's what you're doing. What can we do when the bases are the same? What do we do with the exponents? Right, we add them. So this is 1500. We have 0.01 here minus 5 pennies here. So this is e to the negative 4 pennies t. All right. And we're going to go from 0 off to infinity. Okay, from time now to perpetual. Right. So go ahead and integrate this. Okay. If you need to use a u substitution, then go right ahead. All right. But we just did an integral that looked like e to the kt. We said that's 1 over k, e to the kt. All right. So we're going to move the 1500 outside. Okay. And then here we have 1 over 0.04 negative. Okay. E to the negative 0.04 t. Okay. And we're going from 0 to a, limit as a goes to infinity. Okay. We're going to get rid of this. And we're going to write that an a instead. Right. So we want to make it look kind of formal. We're in calculus class. But you could see, like, I was got too much of a hurry to solve the problem, and I skipped it. Okay, so you have to be careful. You will end up skipping it eventually, but not for a while. So this is 1500, 1.04 e to the negative 0.04 t. And I'm going to do this. I'm going to say this is a to the 0 limit as a goes off to infinity. Okay. What is 15? This I could pull outside 0, right? This is 1500 divided by 0.04. I'm sure that's something. Okay. And then we have e to the negative 0.04 times 0 minus e to the negative 0.04 times a, limit as a goes off to infinity. What's going to happen here? Okay, it's a small number, so it's going to happen slowly. All right. But eventually it's going to get big enough that it's going to start dragging this whole piece down. That it's going to go to 0. Okay. So we have, what is e to the 0, right? Because negative 0.04 times 0 is 0. So we have 1500 divided by 0.04 times 1 minus 0. So let's be careful and say something clever like 1500 divided by 0.04. Remember what happened to the negative? And here we have 3,700. Right? 37,500. All right, let's get rid of that. I like 37,500. Right? So let's see. Very good. All right. I'm going to let you do the rest of these, okay? And hopefully that'll come up with some problems for us, all right? So hopefully you won't have too much problem with it. There's a couple of problems that are a little long, sorry, okay? But you should be able to handle a lot of these, all right? So I'll sign off there, and I think we're going to start chapter 9 next, so see. All right, until next time.